Okay, section 6.3 is actually a little short math lab on investigating graphs of linear functions. And a linear equation is an equation of the form y equals mx plus b, where m and b could be any real number. So we're going to look at what m and b represent now using some graphs and completing the table to kind of see if we can figure out what the m and b stand for. So the first question there gives you 4 graphs, and you have to identify the value of m. So if the linear equation is of the form y equals mx plus b, the value of m in the first example would be 2, because that is the number that's in front of the x, and the value of b is the number that's at the end there, which would be -6. If you calculate the slope for the function y equals 2x minus 6 that's graphed up above here, at the very first graph, you just pick 2 nice points on the line. So I'm just going to pick this point here and this point here. And again, check the x and y axis are both labeled the same. So that means every block can be counted as 1 unit. So we go up from that point 2 units and over to the right 1. So that would be a slope of 2 over 1, rise over 1, 2 over 1, or just 2. If we look at the x-intercept of that line, that's the place where the graph crosses the x-axis, we see that it's 3. If we look at the y-intercept, we notice that it's -6. That's where it crosses the y-axis. So then if we look to the second equation, y equals -3x plus 6, its graph is the second graph above. And if you look at the value of m in the equation, m is what's in front of x, so that's -3. And the b is the last number there, which is 6. And if we go up to the graph for y equals -3x plus 6, and we pick 2 nice points, I'm going to pick this point and this point. And if we calculate the slope of using rise over run, and again all these graphs have the same scale on the x and y axis, so we can just count each block as 1 unit to determine the rise and the run. So we go up 1, 2, 3, and to the left 1, so that would be a -3 over 1, or -3 would be our slope. Our x-intercept is one of the points we used, which is 2. I guess I can say x equals there for that. X equals, y equals, and the y-intercept here would be y equals, where it crosses the y-axis is at 6. The next equation, if you look at the equation, the m is 1/2, and the b is -3, and the third graph is the graph of that equation. So if you look at the slope using 2 points on the graph, and I'll just pick this point here and this point here, we go up 1, right 2, so that's a slope of 1 over 2, or 1/2. The x-intercept is where it crosses the x-axis, that's at 6. And the y-intercept is where it crosses the y-axis, which is at -3. And the last equation, y equals -2/3, x plus 2, the m is -2/3, the b is the 2. The slope of the last line, we pick this nice point and this nice point, the x and y intercept actually, or y and x intercept, we go down 2 and left 3, so that would be positive direction over a negative direction over a positive direction, so that would be -2 over 3 slope. And the x-intercept, if you look at the graph, is crossing over the x-axis at x equals 3. And the y-intercept, the graph is crossing over the y-axis at y equals 2. So if we just look at our findings now on the table, what effect does the value of m seem to have on the graph? Well, if you look at the m, all the m values were matching up with the slopes. So then all the values of m and all the values of the slopes were the same. So m, it appears, represents the slope. Based on your findings, what effect does the value of b have on the graph? So if you look at the b column, the values in the b column, they are matching up with the y-intercept values. So the b is equal to the y-intercept. And that makes sense because if you look at the next question, it says how can you obtain the y-intercept from the equation only? If you look for the y-intercept, as we learned before, you can let x be 0 in your equation. So for example, if I took y equals, our general form y equals mx plus b, and I put 0 into that equation, you would just end up with 0 plus b, or y equals b. So the y-intercept will always be whatever the b value is. And how can you obtain the x-intercept from the equation only? And that would be by letting the y value be 0. Because the x-intercept is where it crosses the x-axis, so every point on the x-axis has a y value of 0. So you just let y equals 0 in the equation. Alright, the last question there. Oops. It says, how can you use the equation in the form y equals mx plus b to quickly sketch the graph? So if you think about that for a minute, and what we did in earlier sections, basically we could use the y-intercept as our starting point and then count slope. So we could plot the y-intercept, then count slope, the m value from this point. Okay, so that's it for this math lab, and we're going to move on to the next section now and use what we've learned in this lab to help us in the next section.